Hey guys, in this video we're going to talk about similarity between geometric figures. We start out with a definition of what similarity is, and our definition is going to be two geometric figures are similar if their corresponding angles are congruent and the ratios of the lengths of their corresponding sides are equal. So we're going to talk about this as we talk about similar triangles throughout a bunch of these examples. The common ratio is called the scale factor. So when we say the ratios of the lengths of the corresponding sides are equal, that ratio, we're going to call the scale factor, and that's something that we're going to find almost every time when we have similarity problems. So we're going to start out with looking at a couple of similar triangles. These two triangles below are similar, and we have triangle ABC and DEF, and you see that the angles are congruent if they have the same little tick mark on there. And this one, A and D, these two match up. These two have two of these little marks, so those match up, which means they're equal. And these have three little marks, and so these match up, which means that they're equal. And so all three angles of both triangles are congruent or equal. And so then the two triangles we are going to call similar. So how are they similar? Well, we now talk about something called the scale factor. And a scale factor basically is a number that will take a triangle and either blow it up to the bigger one and make it the same size and everything. We might even call that a dilation, but it'll make it bigger or it can make it smaller. And so the scale factor depends on if you're going from the small triangle to the big one or the big one to the small one. And so there are actually two scale factors. It's going to be a number, and then you're going to find out that the other one will just be the reciprocal. So the scale factor from ABC to DEF, we need to make a small triangle big. And so it's going to be DE over AB. This one, we're going to do these two. DE over AB is 9 over 6. And so that reduces down to 3 halves. But really, any of these that I would have chosen would also have given 3 halves. This one over this one, 6 over 4 would be 3 halves, or even 4.5 over 3 would still result in 3 halves. And so to go from the small triangle to the big one, to blow it up and dilate it and make it bigger, you just have to multiply the side lengths by 3 halves and you get the bigger one. Now you can go the other way too. The scale factor from DEF to ABC, we now have to make a big triangle smaller. And so we find out that we would just basically take the scale factor and flip it and make it its reciprocal. So 2/3 would be the number that will take you from the big one to the small one. And so you have to choose that number wisely when you're talking about the scale factor from a triangle to another one to make it bigger or smaller. And then finally, we have something called a similarity statement. The similarity statement tells us how the two triangles are related or similar. And we would say the triangle ABC, and this little tilde symbol, little wavy symbol, means similar, is similar to triangle DEF. So ABC, DEF, and you do have to match up the vertices correctly and the sides correctly. You can't just throw any 3 points and any 3 vertices in here. So you couldn't say ACB, DEF, because then the angles wouldn't match up. So AB, DE, AB, DE, AC, DF, AC, DF, and BC, EF, BC, EF. So all 3 of the sides do match up, and they are in proportion to each other. That's another term that I'm going to use, is proportional. Okay, so now we have some problems. This one says if triangle ABC is similar to XYZ, then find the scale factor. So to find the scale factor, we only really need to find one of them, because when we find one, the other one is just going to be the reciprocal. So the scale factor, if I want to go from this triangle to this one, would be a small number, less than 1, because I want a big triangle to go to a small one. So let's do this. To find a scale factor, I'm going to go from AB, XY. So I'm going to match up these two sides, AB over XY. Okay, so AB is 10. XY is 5, and 10 divided by 5 is 2. So the scale factor would be 2. Now that would actually take you from the small one to the big one, but really if you wanted to go from the big one to the small one, you just flip that and make it 1/2. If you chose to pick two other sides though, you could do that. We could have picked BC and YZ. So if we wanted to try BC and YZ, we could do that. BC is 8 and YZ is 4. And we see that 8 over 4 is still equal to 2. And so we get the same scale factor twice. And so it's no coincidence that's how it's supposed to work out. Okay, this one, we have ABC and UVT. So to find the scale factor, I'm just going to keep doing the same thing I am every time. As long as I have all three side lengths, I'm going to do AB and UV. So AB over UV, that's our ratio, is going to be 16 over UV would be 24. I got to be careful. Okay, so now I have to simplify this fraction. So if I simplify this fraction, if I use a calculator, I get 16 divided by 24, which is 0.6 repeating. Well, I know that that's 2/3, but let's say a student doesn't know that that's 2/3. Well, let's simplify our fraction. 8 goes into 16 2 times, and 8 goes into 24 3 times. So we just divide by 8 and divide by 8. And so the scale factor is 2/3, and that's going to take you from the big one to the small one. If you want to go from the small one to the big one, you'll just flip it, and then that would be 3/2. All right, so let's try another one here. Now we have A, B, C, D, E, F, and it's telling us that they do match up. And I don't have this one, and I don't have this one, so I can't match these two sides up. But I do have A, B, and D, E. So I'm going to do those two. So I'm going to do AB over DE. And that's going to give me 8 over 4. And 8 divided by 4 is 2 again. And you do get the same scale factors. They do show up a lot. The same numbers, 2, 3, 1/2, 2/3, things like that, 3/4. It just happens. Okay, this time we need to find the scale factor. And this time we have A, B, C, E, F, D. So again, I'm missing these two, so I can't use A, B, and E, F this time. So I'm going to use B, C, and F, D. Well, B, C is 28. Let me actually write that out for you. B, C, F, D. There's my ratio. B, C is 28. F, D is 16. And 4 goes into both these numbers. 4 goes into 28 7 times. And 4 goes into 16 4 times. So it looks like the scale factor is 7/4. Or to go from the big triangle to the small one, 4/7. Once you find one, you basically have the other one because it's just reciprocal. Okay, so here we have another scale factor one. This time UTS and MPJ. Can't use this one, I can't use this one. So let's try TS and PJ. So let's do TS over PJ. TS is 10. PJ is 15. Let's see, we could divide those by 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. So it looks like the scale factor this time is 2/3 or 3/2. Okay, here we have A, B, C, D, E, F. We have all three sides for both of them. So I'm going to pick A, B, and D, E this time. So A, B over D, E. My ratio. A, B is 24. D, E is 15. I know that 3 goes into both of those. 3 goes into 24 8 times, and 3 goes into 15 5 times. So that's going to be 8 over 5 is my scale factor. This time I have two polygons. Actually, these polygons are quadrilaterals. So A, B, C, D, E, F, G, H. I have all 4 sides of this one and all 4 sides of this one, except for that X right there. So I can't use D, C, and H, G because that one's an X. I don't know that. So let's do A, B, and E, F. Okay, so it works the same way with polygons like this with more sides. So AB over EF would be 12 over 6, and we can just simplify that to 2. So if we want to go from the small triangle to the big one, we just multiply everything by 2, and once you know the scale factor, then you can figure out what your x value is right there. It would just be half of 13. Now we're going to get into some problems here that we have to actually solve. The two triangles below are similar, find x. So the first thing we're going to do is we're going to find our scale factor. So our scale factor, we just need two sides that match up and they both have a side length given. So basically we can do these two. So the scale factor, I'm going to abbreviate SF. Let's do 21 and 7. So 21 over 7 is equal to 3. So the scale factor to go from the small one to the big one is 3, which means if I multiply these side lengths by 3, I'll get the other ones. Well, this is interesting because this one's not given right here, but it matches up with the 6. Well, what's 6 times 3? That would be 18. Now, I don't have to find that one, but I can. I need to find x. So x times 3 is 27. So I need to write that equation. 3x, 3 times x, is equal to 27. Divide by 3, and we get x is equal to 9. So the answer to that one would be 9. Okay, this one says to find x. Let's find our scale factor first. So our scale factor would be, let's see, this one and this one. This is going to be interesting, so like how these match up. Well, it tells us what the similarity statement is right here. A, B, C, D, E, F. Well, we have AB and we have DE. So we can find our scale factor. So the scale factor would be AB over DE, which is going to be 9 over 15. We can divide both of those by 3, and we're going to get 3 over 5. So apparently, to find the other values, we're going to have to multiply by 3/5. So BC matches up to EF. So BC and EF match up, right? So apparently, if I multiply x times not 3/5, but the reciprocal, because I want to go from smaller to bigger, I'm going to have to multiply x times 5/3. So 5/3 x equals, now what matches up to BC over here? That's going to be EF. And EF is 12. So now we see why we have to solve all these equations with fractions early on in our courses, because they come up a lot in geometry. So I'm going to multiply both sides by 3/5, the reciprocal, to get rid of that 5/3 right there. You can do this however you want, but this to me is going to probably be the best way to go. 3/5 times 5/3 cancel out, and x is going to be equal to, and if BC does match up to EF, which is what it's supposed to do, then, and I'm multiplying by the bigger number, yes, okay, then 12 times 3 is 36 over 5 should be my final answer for that one. Okay, this time, these are going to start getting kind of interesting because we have two triangles that are similar, a small one and then a bigger one, and these two sides are parallel. Well, the way you set this up is, what I do is I go from the small triangle first. 8 over 10, and we're going to make a proportion. 8 over 10 is equal to x over, I can't really say 4, I need to really say the whole side from this triangle, which is 14. 10 plus 4 is 14 all the way down. And so that's really the proportion I need to solve. So if we cross multiply, we're going to get 10x is equal to 14 times 8 which is 112. We divide by 10. And 112 divided by 10 is obviously going to be 11.2. And so our x value for this one is 11.2. Let's see, this time, let's see, we're going to have to really be careful with these. Let's see, these two angles match up. These two match up because they are alternate interior angles, and so are these. So I'm going to label my angles first. Okay, so let's go from the small triangle to the big one. So 5.5 over 13.2 equals x, small triangle, x over, and that would be 7.2. Okay, so we're going to cross multiply and we're going to solve. So we're going to get 13.2 times x equals, okay, now we have to do 7.2 times 5.5, and that is 39.6. So if we take 39.6 and we divide it by 13.2, we get 3. And so it turns out that our x value is 3 for that one. Now these proportions can get a little bit trickier. This time we have, let's see, these two angles are going to match up. These are parallel. So this one and this one are alternate interior, and these two are alternate interior. All right, so let's do x plus, let's go from a small triangle. X minus 1 over x plus 3 equals 12, small triangle, over big one, 18. Okay, so we're going to cross multiply. You could actually, if you really wanted to, take the 12 and 18, and you could simplify that and make it 2/3. You could divide them both by 6 right now if you want to, or you can keep the big numbers if you want to do that. It really doesn't matter. If you do cross multiply though, you're going to get 18x minus 18 equals, and then if you multiply those, 12x, and that would be plus 36. Okay, so I'm going to subtract 12x on both sides. 18 minus 12 is 6x. Minus 18 is equal to 36. Add 18 to both sides. And so if we do that, we get 6x is equal to 36 and 18. Well, 36 and 20 make 56. Take 2 away, should be 54. And if we divide by 6, 9 times 6 is 54. So x is equal to 9. All right, here's another one. This time we're given that ABC is similar to CDE. Well, that's good. So we're going to do, I have to work down here, it looks like. Small triangle, x minus 3 over big triangle, x plus 2 equals, here we have our vertical pair, alternate interior, and we're going to do x minus 3 over this one, 4 over 5. Okay, let's cross multiply. 5x minus 15 equals 4x plus 8. Okay, so now I'm going to subtract 4x on both sides. So x minus 15 is equal to 8. Now I'm going to add 15 to both sides. So x equals 15 plus 10 is 25. Take 2 away, so that should be 23. And x is 23 for that one. Okay, so now we have some where we have to find x and y. So we're probably going to have to come up with a scale factor first. So the scale factor looks like these two sides match up. So, and by the way, if two angles of a triangle match up with two angles to the other one, then automatically the third one does. You're going to be taught that in geometry anyway, so let's go ahead and say that. So let's see, 40 over 30, the scale factor, and 40 divided by 30 is really just 4/3. So if I want to go from the small triangle to the big one, I have to multiply by 4/3. So if I want y times 4/3 should give me 36. So 4/3 times y is equal to 36. So let's go ahead and take that and multiply by 3/4 to get rid of it. All right. So these two cancel. Y is equal to 36 divided by 4 is 9, and 9 times 3 is 27. So we got y is 27. So that is good. Okay, now we need to get x. And so to find x, we have to go from the big triangle to the small one. So we need to multiply by the reciprocal of 4/3, which is 3/4, to make it smaller. So that means that 3/4 of x is equal to 18. So I'm going to do the same thing I did before. I'm going to multiply this time by 4/3. The reciprocal to get rid of it over here. X is equal to 18 divided by 3 is 6, and 6 times 4 is 24. So it turns out that y is 27 and x is 24. And you can check that by checking all of your scale factors, and they should all match up. Okay, here's another one. Again, find x and y. So we first need to find a scale factor. Well, if we take these two sides that are matching up, it looks like, and if we're not given any angle values, then we kind of just have to assume that the two triangles as given, like this, are similar just like this, with the angles matching up like that. So 10 and 20. So the scale factor would be, let's do 20 over 10. 20 over 10, because that's 2. So if I want to go from the small triangle to the big one, I multiply by 2. And if I want to go from the big one to the small one, I multiply by 1/2. All right. So to find y, I need to multiply y by 2 to get 35. Okay, so I need to divide by 2. And if we do this, then we're going to take 35 divided by 2, and we get 17.5. So apparently y is 17.5. So you do get decimals quite often. Now we need to find x. Well, we're going from the big one to the small one. So we need to multiply by 1/2. So 1/2 of x is equal to 13. So to get rid of that 1/2, we are going to get another marker here, multiply by 2 on both sides. So if we do that, 2 and 1/2 cancel out because they're multiplicative inverses. X is equal to 13 times 2 is 26. So y was 17.5, if I can write that correctly, and then x is 26 for that one. All right, here's another one. Again, we have to find the scale factor first. We can't do these two, we can't do these two, so we kind of have to do these two. So the scale factor is going to be 32 over 16, and 16 times 2 is 32, so the scale factor is just going to be 2. All right, so to find, let's find x this time first. So to find x, I need to go from the big one to the small one. So I need to multiply by the reciprocal, which is 1/2. So 1/2 of x is equal to 13. So if I multiply both sides by 2, I get x is equal to 13 times 2 is 26 again. Okay, that's just a coincidence. To find y, I have to multiply y by 2 to get 38. So 2 times y is equal to 38. So I divide by 2, and then 38 divided by 2 turns out to be 19. So my y value is 19. Okay, this time, A, B, C, D, E, F, and I have x plus y I need to find, so let's do a scale factor. These are now flipped around. So I'm gonna kind of help myself out. A, B, C, this angle, D, E, F, this angle. So these two angles are matching up. So I'm gonna draw that and that. BCA is EFD. So these two match up. And if those two match up, and they look like they should, then the third angle has to match up. So that one's automatic. Well, let's find our scale factor. We can't do these two. We can do these two. BC and FE. BC and FE, yes. So let's do FE over BC. So FE over BC is going to be 9 over 6. And if you divide those both by 3, you get 3/2. So to go from the bigger to the smaller, then you have to multiply by 2/3. To go from smaller to bigger, you multiply by 3/2. So this one's the bigger, so I'm gonna write big, and this one's smaller, small. All right, so we're gonna find x plus y. So what is x? So x is AC, and then AC matches up to DF, 6. So these two match up. So I've got to multiply that x by 3/2 to get 6. So 3/2 times x is equal to 6. So I'm going to multiply by 2/3, reciprocal. And I'm going to get 6 times 2 is 12. And so 12 divided by 3 is 4. So x has to be 4. And that makes sense because this one's smaller than 6. So it should be 4. Okay, so that's good. Now let's find y. Y is DE. DE is matching up to AB. So if AB is 8 and DE is y, to go from bigger to smaller, I got to multiply by the reciprocal, which is 2/3. So 2/3 of y is equal to 8. So now I'm going to multiply by reciprocal. And some of you may be realizing by now exactly why these numbers are getting bigger or smaller, like they should, because of these scale factors and proportions, or these ratios. So y is equal to 8 divided by 2 is 4 times 3 is 12. So y is 12. Now, does that make sense? Yes, because 12 is bigger than 8, and this is in the big triangle. So x is 4 and y is 12 make perfect sense. Okay, now we have some kind of word problems here. A tree casts a shadow of 13 feet on the ground. A nearby pole is 5 feet tall and casts a shadow of 2 feet on the ground. How tall is the tree? So let's go ahead and let's draw a couple of triangles here. So here's our tree, and it's going to cast a shadow. Let's see, of 13 feet. Now, I don't know how to make these triangles as accurate as possible right now, and I'm not really too worried about that. So I'm just going to draw a couple of triangles here. Okay, so there's one triangle. There's my tree. And it says the tree casts a shadow of 13 feet on the ground. A nearby pole is 5 feet tall. So let's draw the pole. And it's just a pole. So let's assume it's like a flagpole. So I'm going to try and make my drawing look decent. Okay, so there's a pole. Don't know, don't have any idea about this distance, but it does say cast a shadow of 2 feet on the ground. So I'll try and make it somewhat accurate here. Okay, so the nearby pole is 5 feet tall and casts a shadow of 2 feet on the ground. How tall is the tree? So we don't know how tall the tree is, so I'm going to call that H. You can call X, whatever you want. I'm going to call it H. So we have two similar triangles, and we are going to now set them up. So there is a proportion we need to use. H over 5, height over height, is equal to 13 over 2, shadow over shadow. Now there is another way to do this, but to not confuse people, I want to do it the same way every time. So height over height, shadow over shadow. Then we cross multiply. So 2 times H is equal to 13 times 5. So we do 13 times 5 and we get 65. So we're going to get a decimal, which is pretty common. So we divide that by 2 and we get 32.5. So H is equal to 32.5 feet. And we have another word problem here. This one, a 24-foot tall tree casts a shadow of 30 feet. How long will the shadow of a 5-foot tall person be who is standing next to the tree? Okay, so let's do a tree over here. And we're going to have a shadow, so I'll use another color. And depending on the time of day, it depends on if it's a long shadow or a short shadow. So I'm just going to draw a basic shadow. Okay, so we have 24-foot tall tree, so that's 24. Cast a shadow 30 feet. All right, now let's do the person. So the person, it's a terrible person, but it'll work. And that person is going to cast a shadow of some distance. And that person is 5 feet tall, but we do not know how long the shadow will be. So I'll call the length of the shadow L. Okay, but we have proportions though. We have 20 height over height, 24 over 5 is equal to shadow over shadow. We do have to take the same numbers from the same triangles for the numerator and denominator too each time. So 24 over 5, 30 over L. Again, there are other ways to set this up, but I'm trying to be consistent. So we need to do 24 times L, it's a proportion, is equal to 30 times 5 is 150. So now we're going to divide both sides by 24. And now we're going to do 150 divided by 24, and we get 6.25. So 6.25 feet is the length of the shadow cast by the person. All right, and it's longer than the height of the person, just like the shadow of the tree is longer than the actual height of the tree. So that makes sense. All right, guys, this has been Similarity. And make sure you like my video, subscribe to my channel if you haven't already. We'll see you guys later. Bye.